Hello again. In previous presentations, we talked about the sort of big picture behind EDA and the mechanics of how the various component standards play together. In this discussion, we'll focus in on the E120 and E125 standards. E120 is basically the equipment description componentry, and E125 defines all the services by which those components are requested by host systems to understand what's capable to be collected from the equipment. So the E120 and E125 standards talk about the equipment model. E164, which is the EDA common metadata, is a deep enough topic to really justify a completely separate discussion. So we'll save that one for later. So first of all, E120 is a static description of the components that go together to form an equipment model. And there are only a handful. There's an equipment, there's a module level, a subsystem level, and an I/O device level. And so a piece of equipment, regardless of how complex or simple, can be composed by nesting these 4 or 5 component types together. And this forms the static structure of the equipment. Now, it's important to realize that this structure is really up to the equipment supplier to define. It can be a very close match to the physical architecture of the equipment, or it can be completely different. I mean, ideally, it should be as logical a representation of the equipment as possible, because this is the structure that the data collection applications are going to see, but that's not actually a firm requirement. The E125 standard is the so-called equipment self-description, and that's a list of services by which you can request the individual component parts of the model. And so the E125, for example, has services for requesting the overall equipment structure. The equipment structure lists all of the other components that are there, and then you can request each of those individually. It also has a request for all the state machines, all of the units, all of the parameters. So every different type of information in the equipment can be requested with individual services. It's probably more useful to actually look at an example than it is to describe them, because it's much more instructive. So I'm going to run some software here that we'll be using to browse an actual equipment model of a GEM 300 compliant piece of equipment. So what I'm running here is actually a piece of software called the Equipment Client Connection Emulator. It's a software that Symmetrics had developed long ago to actually help people develop implementations of the standard. And so it's a very good way of actually exploring interfaces and model components, a very instructive tool. So what we're showing here now is the top level of an equipment model. You'll see each of the high-level components are represented by a green icon. In this particular model, there are 2 processing chambers, 1 front-end module, and a substrate aligner. These are hardware components. And then you have 3 or 4 more components that are actually software components in the model. And each one of these, of course, can be expanded into its component parts. And so each module can have a list of parameters assigned at whatever level they need to be. State machines are shown in blue. State machines, of course, underneath them have transition events and the parameters that are associated with each of those transition events. And so you can see even a fairly simple tool may end up having a fairly complicated model when it's all said and done. Let's see. Let's just narrow in on an example here just to show how the pieces work. If you look at substrate location, one of the requirements of a model is to have a place in the model for every place that a substrate can be. And there is a very simple state model defined by the SIMI standards, the E90 standards, for substrate location tracking. And the basic idea is that substrate location is either unoccupied or occupied, and there are transition events that move you from one of those states to another. When each of those transitions happens, there may be data that's available for each one of those. And so if we look into the event from, let's say, unoccupied to occupied, you'll see that the two parameters that are available there are the substrate location ID, in other words, which one are you looking at, and what is the substrate ID of the wafer that is now landed on that substrate location. And so whenever the transition goes from unoccupied to occupied, you will have available that information. Likewise, when the wafer leaves, the transition will be occupied to unoccupied, and you'll have the same information. Which location is it and which wafer just left? So this is just one example of a piece of the model, but you can see that every event or parameter or exception in the entire piece of equipment is defined in this model. To look at the actual information that is in the E125 standard, if we go back to when the tool was first connected, you can see the actual E125 events, E125 messages that were present that were executed to upload that model. Okay, what I have just run was an initial connection to a piece of equipment using EDA, and you can see here at the front that looking on the SOAP logging tab, you can see the established session message that I referred to, some E125 commands that say tell me about any revisions to the model, and then you have a list of E125 messages that request the equipment structure, the units, the type definitions, the exceptions, state machines, all of that information about the model. And then, of course, the equipment structure had a list of all of the individual nodes in the equipment, and then there's a request for each of those node descriptions. You can get into the details of the XML for each of those if you choose, but again, this is the equipment metadata model request that you have. So this shows how the actual model is defined and how it's requested by an application. And in another session, we'll get into the details of what it means to have an E164 compliant model, because the structure, content, naming conventions, a lot of that are specified for you. And then you can, for an individual piece of equipment, add the specifics for that process type. But that's a topic for another session. Thank you.